Hi, in this video we're going to implement a hash table, and this hash table will store a lot of English words. At present we are storing all these words in an array, and since this array is growing very fast, the search activity is taking a lot of time. To implement this hash table, I have written a very simple hash function and shared how its characteristics fare against a typical hash function. As you've noticed, it didn't do very well. Still, we will see how useful this function is in implementing a hash table. If you want to know more about the characteristics, I request you to have a look at the previous video. Although the hash function does not look very promising, we'll use this function to test the distribution of data in the hash table. And for this testing, I'm using a hash table with 5 buckets. The input for the testing is a text file with 30k English words. This test will count the number of words that will fall in each bucket. Let's have a look at the test function. We start with creating a dictionary with 5 keys. Each key represents a bucket, and the value of each key is the count of words stored in a bucket. The next step is to read the words from a file, and each line contains one word. Now for each word, we generate the hash value using our hash function. Then we calculate the hash index from this hash value and increment the dictionary count. And finally, we display the distribution of the words in this dictionary. By looking at the results, this hash function has done a decent job of distributing the words with a variation of around 3%. But what if this variation is not acceptable? Well, in this case, we can play around with the bucket size to find an optimal setting. And if this change of the bucket size too is of little help, well, in that case, the only option left is to look for a new hash function. The code used in this video is available on GitHub, and the link is shared in the description below. Once we implement the hash table, the job is not done. So it needs a constant vigil. So whenever we test with limited data. And when more data is added, it has a potential to create a hotspot. A hotspot occurs when the data distribution becomes uneven and a few buckets get more data as compared to the others. Another point to monitor is the frequently accessed location, or the buckets in this case. So when a lot of data is modified and searched for in few buckets, this can also lead to performance degradation. So one approach to address these issues is to resize the hash table. And the biggest disadvantage of this approach is the recalculation of all the indexes, which can be a time-consuming activity. Or we look for a better hash function that distributes hash values evenly. To summarize this video, select a hash function as per the need, test the hash function thoroughly, evaluate the results and choose the hash function accordingly. You constantly observe the impact of the new data added to the hash table. And to avoid any hotspots, change the bucket count and/or change the hash function if needed. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.